Hello, in this video let's discuss third question of today's contest. You are given an integer nums. Your task is to find two distinct indices I and j such that the product v of I into v of j is maximized and the binary representations of v of I and v of j do not share any common set bits. Return the maximum possible product of such pair. If no such pair exists, then return 0. The constraints are the length is up to 105 and the values are up to 106. So given an array, we have to return the maximum product such that the bitwise and is 0 for both. So only then it means that there are no set bits, right? For example, if the two numbers are 10 and 11, they have one set in common. So the bitwise and is non-zero. So this is not correct. So this pair we cannot select this pair. So we have to select two numbers such that the bitwise and is 0, and we have to return the maximum product if there are many pairs. N is up to 105 and V of I is up to 106. So for example, we are at index I. We are at index I, and the first thing that we can think is what are the indices j such that the bitwise and is 0. So if we are at index I, which day we have to consider so that the bitwise and is 0. So firstly, we can go to all indices except I, and we can find whether the bitwise and is 0. If it is 0, then we can find maximum of that into v of j, and we can try to maximize. But it will be n square, which will not pass. So let's represent the numbers in binary so that we can get any idea. So let's assume the values are 1, 2, 3, 4. So the binary representations are 0, 0, 1, 1, 0, 1, 1, and 1, 0, 0. So these are binary representations of 1, 2, 3, 4. For example, we are at 4. So if we are at 4, so we are at 100. We are at 100. So what is the bitwise and which will give this with 0? Which will give with this 0? It will be simply 0, 1, 1. So this is the first thing. So for 100, we have 0, 1, 1, which will give the bitwise and with 0. So for a number, we already have its complement, right? So for 100, we already have that the complement will be 1, 0, 0, 1, 1. So if it exists, then find the maximum with the product, else continue. So from this, what we got? So for a given number, we already have a complement mask or complement number with the binary representation. So if we have this, then we can find this also. So initially, if we store all the numbers in the map, then we can simply find if that complement exists in the map. If there exists, then we can simply find the maximum of that value and this value. If it is not, then we can continue. So is this actually correct? Actually no. For example, if the number is 100, but for now we are thinking about 011. But what about 010? What about 001 or 000? Because for example, it is satisfying for 011. It will satisfy for 010 also, right? For example, because it should not be a violation. There can be an extra zeros also, but there should not be any set bit. For example, a number's complement is 011. So can that consider number 010? Obviously it can consider. Why? Because the only condition here is there should not be any set bit. The bitwise and must be 0. So even these bitwise and is 0. The only thing difference is this bit. The only difference is this bit, yes. So this is the complement and this bit is unset from this. So even then there is no problem, because the only restriction that we have is two numbers must have the bitwise and a 0. So even that may be 011 or 010 or 001 or 000, we don't care. So for a given number, we can have many different binary representations or numbers that have bitwise and with 0. So 100. So next three are subsets of 011. So for 100, we are thinking about the main one, which is 011, but there can be many other different subsets of this also, so that it can be satisfied for that also. So we discussed, right? For example, if a pair has a complement 011, then we can consider the complement as 010 also, because the only restriction is bitwise and is 0. So even now for 010, the bitwise and is 0 with 100. So for 011, all subsets of this also will be a valid possibility for 100. So hope you got this. And then if a number has 011 as friend, it can be friend with any other subset also, but not 100. For example, but not 110, right? So The complement can be 0, 1, 1 or any of these four, but not 1, 1, 0. Why not 1, 1, 0? Because with 1, 1, 0 and 1, 1, 0, we have a bitwise unread. We have a set bit and the bitwise and is 4. So this is not possible. So we cannot select this 100, 1, 1, 0. So we can take only all subsets of the main mask font, which is simply 0, 1, 1. So here, but even now we can't generate all right. For example, for 4, we got 4 possibilities. What are the 4? These 4, 0, 1, 1 and all these 4. So, but for big numbers, there can be many other subsets also. For example, if the number is 0, 0, 0, 0, 0, 1. So if this is the case, then what will be the main complement? It will be 1, 1, 1, 1, 1, 0. So this is the main complement. So for this, there can be 2 power 5 subsets, because this one can be 0 or 1, this one can be 0 or 1 and so on. This 0 must be 0, right? If this is 1, it means that we have common bit. So for 0 it is 0. For every one we have 2 possibilities. So for this we have 32 possibilities. So in this way we have 10 power, the range is 10 power 6. So if we try to generate for all numbers, it will give TLE. Because for 10 power 6, maybe we can have 2 power 18 subsets to check, which will give TLE for sure. So how can you optimize this? So what if we have something like maximum of some number, right? For example, what is the main criteria here? We want the maximum product. For example, we have 0, 1, 1. So 0, 1, 1, what if we directly have the maximum value that have 0, 1, 1? Then it will be simple, right? So we are thinking about it. So simply, what if we have max of number that gives the maximum v of k such that it is binary? It is not exactly binary. If that is binary, then simply maximum of binary is binary. Is that number? For example, maximum of 3 is simply 3, right? So only 3 is the value that can have bitwise. It can have number as 3. So maximum of 3 is 3. But our main goal here is to find all of is to incorporate all of these 0, 0, 0, 0, 0, 1 or 0, 1, 0 in 0, 1, 1, so that we can check only 0, 1, 1 and then we can get answer for whole instead of traversing for all the subsets of 0, 1, 1, right? So here, for example, we got number as 1, 0, 0. So what is the main complement was? It is 0, 1, 1. So our main goal now is to find this answer in O of 1 or maybe in pre-computed. Maybe pre-computed is O of n log n, but if it is pre-computed, now we can access in O of 1. So for 100, if we find the answer of 0, 1, 1 in O of 1, then it will be great. Then we can simply loop through the values and then we can find the answer for complement. So the main goal now is to find the maximum value such that it have the binary representation of 0, 1, 1. But it is not exactly 0, 1, 1. So it can be 0, 1, 1 or 0, 1, 0 or anything. So now the main goal is to find the maximum binary representation such that all its submasks are also considered in that. So that if we are trying to access this, this will have already pre-computed as 0, 1, 0, 1, 0, 0, 0, 1 and 0, 0, 0 in this. So we can simply return in of 1. So hope you got this. So what if you have something like maximum binary representation? So that will contain the maximum value that have the binary representation subset of this one. So maximum of 110. So what it will consider? So it will consider maximum of 110, maximum of 010, maximum of 100, and maximum of 000. So in this way, if we try to have this in handy, then if we are trying in the loop and we got 0, if we got 001, so if we got 001, we will find the maximum of main submask, and which is already having the result combined for all its submasks also, so that we can find this in of 1 and then we can find the maximum answer. So now our main goal is to find the maximum of binary representation such that it will incorporate all the results of its submasks also in the maximum value. So now how can we do this? So we can simply use mask. For example, let's say we have 1101 and 1101, what is that? It is simply 0123841. So it is 13. So for 1101, the number is 13. So without it considering any submask, the maximum value of 110 1101 is 13 itself, because we are not considering anything, it is submasks. So simply the value is the maximum value for now. So for 1101 the maximum value is 13. So now we have to incorporate all these submasks in 13, right? So of this to 44, but it will be 2. Yeah, but even now we have to traverse all the set bits, we have to traverse all the bits, and then we have to find the possibilities. If there is 1, if there is 0, it should be 0. If there is 1, it should be 0 1 again. So we cannot do that, it will give tail. So let's break these in terms of layers. So so there are how many? There are 8 different possibilities, because 2 into 2 into 2. So we have 8 different possibilities. So let's try to differentiate those. So these 3 come belongs to first set, these 3 belongs to second set, and this belongs to third set. So why are these different? So for 1101, what if we try to different, what if we try to make a set bit off? So we can try to make this set bit off, then it will become 0101. If we try to make this, it will be 1001. If we try to make this, it will be 1100. And now these are the set of values where exactly one bit is different, one set bit is different. And now we can try to make other set bit from this, so that we can get second layer. So we can remove this also to get 0100. So we can get 0100 also. So similarly we can get second layer also, and then we can try to remove this also, so then we'll ultimately get 0000. So we separate this into sets. So now what we are thinking, so we are thinking that for a value 1101, we have to generate all its subsets, so that only then we can find the answer. But what? So indirectly it is like we are at 1101, we are going to all of these, the first set, we are going to all of the second set, we are going to third set. But is that really required, which is giving daily? So it is not clearly required. For example, we have 1101. So let's say this is the only first layer. Let's say this is the second layer, and third layer is 0. So this is 0100, right? So we have these resets. So what we are considering now? So now we are thinking that we have to traverse through all of these. We have through all of these. We have to traverse through all of these, and then we can find the answer. But what if this has already pre-computed answer for this layer? What if this already pre-computed for this one? So if that is already pre-computed, then for a submask, then it is just sufficient to traverse through its set where it exactly different in one bit. So what I'm saying is, for example, we have these all. So for now, for 1101, we are traversing through each and every subset to find the maximum. But what if we have already answers computed for 1101, for 1101 in its subset? So for example, when we are finding answer for 1101, what if we directly have maximum of 1100 as all the possibilities with the next layers also? Then it is enough just to traverse through these 3 numbers, right? So that already all these results are already in this mx vector. So now we can directly access in of 1. So how we got this? So instead of traversing each and every layer at a single value, let's just try to think of the next layer with exactly one different set bit. And this also will have one layer, this also will have other layer. So gradually the numbers go to 0, because this is the final value we got here, right? So what if we start from 0? So we will start from all bit masks from 0 to 1e9, 0 to 1e6, which is the maximum value. So we will go to that, and we will we will go to all the complement sub, we will go to all the submasks. We will go to all the submasks of sit, and then we will try to offer set bit in every time. So we'll get many different possibilities where it have exactly one set bit in different. So if there is one, we will make this 0. If there is other one, we will make that 0. If there is other, we will make that 0. So in this way, we will try to find all the subsets of this, and maximum of maximum of 110 will already contain the answer considering all the submasks. So now when we are coming for 1101, so we discussed that we are coming from small to high, right? So when we are coming from 1101, we already have the answer for 1100. So instead of simply traversing each and every subset again, it is just enough to consider for 1100, 1001 and 0001, right? So it is enough to traverse through all these three. So in this way, for 1e6, it is just enough to travel 19 at most. Why 19? Because 2 power 19 is the maximum value that can have less than 1e6. So instead of traversing all subsets, we can just traverse all the bits so that we can get the answer in less than 1e8. So hope you got this. So it is sufficient to deal with the first set if they're already processed. So start from 0 and for every mask till 2 power 19 do the operation. So now at a number, we can go through numbers that have one set be different. And why we are not considering the before one? Because they're already incorporated in this one. These are already incorporated in this one. Because when we are doing operation for this, we consider this one, right? We consider one back, one set layer. So indirectly, it is just enough to see to the previous layer. So hope you got this. So let's check the code. So if we observe, the time complexity of this is always 1e9, 1e6 into 19, because we are traversing from 1 to 1e6 always. We can try to optimize that also, but almost the time complexity will be 1e6 into 19. But that may not be the case for very small. If the numbers are up to 2, if they are less than or equal to 2000, then no need to do this because we can directly get answer in 1e6, which is more than this, which is less than this. So we can just choose a simple one, so that if the numbers are less than or equal to 2000, then we can simply use the brute force to get the answer. So if that is not, then we can try to use this approach, because this will overall reduce time complexity. For example, we have 100 test cases. So we have 100 test cases, and there are 100, there are 10 test cases with less than or equal to 2000, and rest of the 90 having greater than or equal to 2000. So initially, if we try to use only this, then we may get more time complexity. But if we try to just use less than 2000 the brute force, then it will be much faster overall, right? That may not be beneficial, that but this is better than the original one, because for smaller complexities, for smaller n, we can simply find the answer in n square instead of 1e6 into 19. So if it is less than or equal to 2000, do brute force. If it is not, then start reversing, right? So find the max vector. Initially it is 0, it means that there is no value, and then use the max is equal to it itself. So initially, if there is IT, the maximum of your IT is IT itself. And then start traversing through all the bits and then all the submasks. So at a mask, we are at a mask m. So if bth bit is set in mask m, it means that we are finding the maximum with m XOR that bit. That means we are indirectly offing the bit. So this was exactly layering one set, right? So we are at 1101. So what the code is doing, so we are going through all this mask, and if this bit is set, we are doing maximum of 0101 and 1101, right? And then we will traverse, we will come to this bit, and we will find the maximum of 1001, and then we will come to this one and we will make 1100. So in this way, these three are the possibilities for first layer. So we will find the maximum of this, and maximum of this and maximum of this. So in this way, we are trying to cover all the possibilities with just traversing in of 19. We are traversing only one layer backward with one set exactly different. So if that is done, it means that it is set. So if it is set, we are offing that. That means that we are considering all the rest of the mask except that bit, so that we are XORing that. So hope you got this. So after completion of this loop, what we will get? The loop will say the maximum value of IT is the maximum value of IT such that all the submasks of IT are also considered. And now let's make answer 0 and traverse through all the numbers, and mask is 0 and traverse and just find the mask for now. So find the mask of this number. So we found mask of the number, so just simply traverse, and if it is set, then simply make OR. So for example, we have 8, we have 9. So it is simply 1001. So simply this is the final mask that we will get. So this is the mask, and then we want the friend mask, that we want the complement mask. So how can we find the ultimate complement mask? So for example, we have 100100. So how can you find? So Let's try to flip all the bits of this number. So simply not of this mask, what it will become? It will become, so even if there are zeros, it will be 1 1 0 1 1 0 1 1. But we only want till this one. We only want till MSB of this, because rest of this must be 0, right? So what if we try to just, because the numbers are only up to 1 is 6, right? So we have to restrict that to 1 is 6. Maybe there can have ones also, but we have to restrict to 1 is 6. So simply not mask. This means that it will negate all the bits of the number. So negate the bits, and then bitwise and with 2 power 20 minus 1. So what is 2 power 20 minus 1? So 2 power 20 minus 1 is simply the 1 1 1 1 1 answer, where the highest bit is 19 and the least bit is 0. So 111 is simply 2 power 20 minus 1. So we are just doing this with the bitwise and of 1111, so that we can restrict the number till only 19 bits, till 2 power 19 bits. So approximately 20. So 2 power 19. So hope you got this. So A and A. So A and 1, what is that? It is simply A. Because if A is 1, it is 1. If A is 0, it is 0. So why are we making AND with number? So it is simply we are restricting the number to 20 bits. We are making all the other bits to 0. All the right bits to 0. From bits 21 to highest number as possible. So if the mask is greater than 0, it means that it is existing. So then find the maximum product. IT into max. So in this way we can find the answer. If you have any doubts, comment below. See you in the next video.